All right, so I'm on the pros and cons section for symmetric key cryptography systems. All right, so I don't know when exactly the meeting stopped, so I'm just going, just for benefit of everyone, I'm going to kind of share it from this slide onwards. So the pros include that the symmetric key systems are very effective with respect to computational speed. All right, so because the same key is used for encryption as well as decryption, it is very fast, and it is an ideal system for communicating because of the speed and the efficiency that we can get. Okay, even with a smaller key size, we are going to get fairly secure systems, and we'll talk about the different key sizes in the coming slides, coming hours. Uh, but just know that if we are able to get into a place where we can use symmetric key cryptography for communicating, that would be the ideal state, because it's because of the computational efficiency. The weakness, or something which we have to take care of, is it requires a secure mechanism for key exchange, right? So you have to have a secure mechanism wherein you are able to exchange the keys that we want to use during the communication. All right, so that is a I wouldn't say it's a overhead, additional overhead for using asymmetric key cryptography. Okay, and if you are using if you are communicating with many people, you shouldn't be using the same key every or in multiple places. It has to be unique, right? So that is one thing which you have to keep in mind. And because it is just a same key, right, it does not provide you cannot really know who actually has it. So you cannot say that, okay, it does not have that additional feature of verifying the recipient or the center of the information. Okay, so we can talk about this particular thing when we are discussing about the key exchanges also. So just moving on. So there are two ways of actually implementing the symmetric key cryptography. One is using the block ciphers, where you take a block of data. So it is recommended to use block ciphers when you know what is the length of the overall message or the data, right? So if you know that, you can convert them into blocks of data and then encrypt each block one at a time. Okay, so some of the popular ones are data encryption standard. You had triple DES, and there was a double DES, which was almost same as had same issues as DES, so that was never popular. There is also blowfish, which is pretty good. Sometimes it is even used right now in the current scenario. And there's one more called as International Data Encryption Algorithm, called as IDEA. So this is also a very good. It has very less. I don't think it has any known attacks at all. But the thing is, it is patented, and you have to pay the royalty to use that particular algorithm. So that's why the usage is fairly restricted. So at a point of time when the DES as well as triple DES were no longer effective, the reason being it could be broken with the latest technology and the computing power that was being built. The DS or the triple DS was being able to be cracked in a reasonable amount of time. So NIST had to come up with a new standard which is going to stand test of time, and the computational power which people have access, both good guys as well as bad guys. So it opened a competition for the next standard, which would be used everywhere, right? So that was a call for a algorithm which is fairly mathematically strong, provides very good encryption, as well as it is usable in software as well as hardware use cases, right? There were many candidates, MARS, RC6, Serpent, Two Fish, and there were few others also. These were the final candidates, which were I think five were the final candidates, but there were other candidates which applied for it. But the Regendol algorithm was finally chosen, and that is used as the AES standard or the advanced encryption standard, right? And if you look at when I talk about block ciphers, that is AES, the Argendal, I believe it's a block cipher. And with respect to the other type of ciphers, it is stream cipher. It is when you don't know when the data is going to stop, or it's like a continuous data. For example, it could be music data, video data. It probably it's keep on coming. So it is going to uh, encrypt almost like a bit at a time or a stream of data at a time. So a lot of algorithms are there, the RC series like RC4, RC5. So these are some of the algorithms which are there with respect to stream cipher, right? So what uh, we use right now is we prefer to use is AES, and there is some comparison bit from the data encryption standard as well as the advanced encryption standard, which was finally uh, you know uh, taken into the public domain in 2000. Is that it is a symmetric block cipher. It has a block size of at least 128 bits, and it has other variations also of 192 and 256 bits. So the AES 256 is, I believe, very strong as well as very popular these days. When I say popular, if you look at how Amazon Web Services they encrypt data at rest in the cloud, right? They use AES 256 and many other cloud providers, and it has become a de facto standard, right? The DS has been like phased out, and it has been proven inadequate because of the computational power which is existing right now in the world. All right, so we'll also do some hands-on activities on this in just a bit after we cover some topics on theoretical concepts, right? So asymmetric systems. So what are the pros? So pros is that you have better scalability. So you don't you have you can leverage the encryption to do more things than just confidentiality. You can use it for authentication as well as non-repudiation. For example, if someone is able to decrypt a particular key using the and has the encrypted text and able to decrypt, they can for sure say that okay, this message has been sent by a particular person. So that is the digital signature part, which we're going to see in just a few slides, right? Or it could be that we are encrypting the message and only a specific person will be able to uh, decrypt that. So if we are able to see it, it means that okay, so it cannot be anyone else who has seen the message. It is only him who has seen the message. So it works both ways. Okay, either you encrypt and send it to others, or everyone encrypts and sends it to you. So these are two different use cases where asymmetric key systems are used. So we are going to see examples for both of them. So I think that will answer the question which the earlier gentleman had asked during the session. All right. Cons include, computationally it is slower compared to the symmetric key cryptography, and mathematically intensive. That is understandable because of the complexity involved. Okay, there are several algorithms. RSA, Rives Shamir and Adelman together wrote a paper, and that is used very widely. And elliptic curve crypto system or cryptography, which is very popular these days, and it can provide uh, uh, similar security with lesser key size. Okay, we are going to see the workings of elliptic curve cryptography. We are going to do a lot of work with actual curves, elliptic key curves, I believe we'll be able to do it tomorrow morning, so stay tuned for that. We are going to work on elliptic curves, build uh, build the graphs, and learn from there. All right. Diffie-Hellman is one of the well-known key exchange schemes which can be used for sharing keys on a public medium without having to actually go and whisper the key secret to the other person, right? So there are a lot of algorithms here, so we are going to concentrate on the first two to understand it a little bit better. Okay. So if you think about the comparisons between an RSA algorithm as well as the elliptic curve cryptography based algorithms. Uh, if so, currently I will be doing some hands-on as well on this topic. The RSA key, it is 2048, is being considered as a fairly secure key size for an RSA algorithm, for a system which uses RSA algorithm. Okay. Uh, Corresponding same level of security can be provided by elliptic curve cryptography algorithm if it uses just a fraction of the key size, that is just to under 255 key size. If it uses, it provides the same level of security as the RSA 2048 keys provides. Okay. What does it mean? It means that you can get better security at a lesser size. And nowadays I have seen many organizations using elliptic curve cryptography with size of 256 bit, so which is even better compared to RSA 2048. All right, so we'll see these things in working, all right, in just a few minutes when we shift over to the hands-on part. Okay. So the key exchange, I believe we would all be kind of exposed to it at some point of time, because these are concepts covered in our computer networks as well as all the cryptography topics. But I just wanted to share this. If there are Bob and Alice, and each of them have their own public key and private key. Okay, public key is something which Bob shares with can share with anyone in the world, and private key is something which needs to be kept with themselves, right? And the way in which key exchange mechanism works is, uh, from the Alice side, they use their own. Alice uses her own private key and Bob's public key, and a combination, a mathematical function is results in a particular shared secret, which is similar to what is computed when Bob's private key is mixed with Alice's public key. All right. So the final value. So even if Bob's public key and private key is combined, the shared secret will be same when Alice's public key and private key are combined. So this in this way, this is a shared secret. So if this particular secret is used as a key for symmetric key functions, finally they would be able to just confirm that, okay, so it's a message which is exchanged between Alice and Bob, and this is something which will be kept as Alice and Bob's shared secret. This should not be shared with others, but it is shared between these two based on the public key as well as private key. So Alice has Bob's public key, and Bob has Alice's public key. So Alice does not have Bob's private key, or Bob does not have Alice's private key. Still, they can communicate to each other using the shared secret. So that's how the usual, the key exchange scheme works. So Delphi-Hellman algorithm is one of the most popular algorithms for doing that. Okay, so at this point of time, I would like to just take a small break, and I want to share some tools, and I'm going to share these tools with you. Some of them have code which you can implement at your end for your own project use cases, and some of them are freewares which are available just for usage on the website. Okay, so let's start with understanding. So we started with encoding, right? So let's start with understanding encoding. So what I'm going to do is I'm going to stop sharing and I'm going to share my browser so that you'll be able to see what I'm doing. Okay, let me know once you can see the browser. Is the browser visible?
Yes, sir.
Perfect. Thank you so much. Thank you. So I'm going to use this particular URL. So you can, there are multiple implementations of this, and many of these have provided their GitHub repository for you can use it with a with a copyright license. You can implement it for your own purposes, and many of the programming languages have libraries which have inbuilt functions to do it. Okay, so just for learning purpose, uh, anything here. So I am enjoying blockchain. Okay, so let's put this, and this is UTF. So you can see that there are a lot of algorithms which are there for encoding, and the popular ones are UTF-8, ASCII, and some ISO related ISO standards, right? So let's use UTF-8. Okay, so you can see that even the space, the special characters, the exclamatory mark, so everything has its own value, right? And it is encoded with that particular value. It has different uh, different applications, and even you have things like a bit URL, right? So you want to share a shortened URL, so that also uses encoding, proprietary encoding methodology, right? So that is one. Okay, so let's go. So I want to understand about base 64 encode decode, because that is one of the popular encoding mechanisms. The reason being, in many cases, if they instead of hashing, they just store it in base 64 and store it in database. So please remember, if you are storing any confidential information in the database or any other place, encoding is not for providing security. It's just a data representation, data mapping, right? So some, even if you say some confidential information, if you want to use, oh, I think I'm still, the file is still getting loaded. Okay, so even if you want to encode it to base 64 format, right? Let me just, so it is not going to help you. So even if it's looks like a gibberish, right? Even if it looks like a gibberish, it is not going to help you with security. The reason being, you can, somebody can just take it and they can just go decode this information and get back the original text. They just need to know that it is using base 64 format, and by looking at the characters, you will be able to make out that it is using base 64. Okay, so if you want, so it's just a one of the things that we see when we are doing penetration testing and security analysis of the applications and systems, right? So people use base 64 for as a instead of using hashing, they're using base 64 to encrypt, or they think that it is encrypt, but it's not encrypt, it's just encoding of the data, right? So just a word of caution to you. So that is one. And let's do a little bit. So I'm going to type this till here we are going to cover right now. So what I'm going to do is I'm just putting it in the chat for you to try it out yourself. So I want this to be you know, even though it by design it cannot be interactive because of the it will become very cumbersome. I want you to try it yourself. Okay, so so I want you to see if where you can use these techniques and implement in your project work or any research work. Okay, so again, so these topics are the basic ones for you to get the grasp on the subject, and the heavy duty blockchain technology, ethereum, everything is coming up, so stay tuned for that. So I had just done the uh, attack at dawn example in the morning, so it has just picked up that cookie. So let's say attack at dawn. So let's so shift is 3. So this can be modified, so I can make it as 5 and then encrypt using the Caesar code. Okay, so Caesar code shift by 5, so A will be replaced by F and so on. So this is the result for the Caesar encoder or encrypt, whatever you want to call it. Okay, so here I have selected this and I want to say, I want to kind of decrypt this particular message. Okay, so if I don't know the particular shift value, even if I say decrypt, I'll get gibberish. I will not have anything, right? So only thing which I can do is I have to test all possible shifts using brute force, and I will come to know. So this is +5. So the same key which we have used is the one which is giving the best answer, and everything else seems gibberish, right? So it means that the key value is 5. So again, so this was used a long time back, and it used to take a long time for people to figure it out. So it still used to work, but someone, if he had figured it out somehow by finding out just for a small group of characters and then extrapolating it to the entire message, it would have been a smart way of getting to know the information, right? So this is one, and there are a lot of similar what I can say similar uh, functions which are used. One of the popular ones is rot 13. Okay, so rot 13 is used to let's test it out. Blockchain. So let's it's a 13 shifts, right? So you can use this to decrypt. So if this is 13, you will get to know, or if it is a set of characters also included, then it will be a different one. But if it is just numbers are included, it will be a bigger set. The modular function will be more. If it is just A to Z, blockchain answer will be the answer for the 13 shifts. There is also ROT 18, which includes the numbers like we just mentioned, right? It includes for messages which has alphabets as well as the numbers. So right now there is very little use for these, but we have to understand that the basic concepts of how the encoding and the decoding happens. Okay, so I think we have covered this. So let's go to the next topic, which is the symmetric key cryptography. Okay, again, it's a implementation of symmetric key. So it's a basic implementation just for our understanding purpose. The real world implementation would be much more complex, right? So let's generate a symmetric key. So a random number will be used for generating the symmetric key, and we are going to talk about random numbers hopefully at the end of this particular session, which plays a very key role with respect to cryptographic functions. All right, so this is a asymmetric key, and this is a plain text message. So test message, and symmetric key is 50. So you can just mention 50 here, and then encrypt using symmetric key. So this is the encrypted message. This is a what I can call implementation provided by the author. It's not a standard implementation, but it's okay. So let's put it here. And symmetric key, unless someone knows the symmetric key, they'll not be able to get back the decrypted message. So let's try different numbers. So you can see the answers which is churned out is again some kind of gibberish which is not making any sense. So it will be different for different thing. But if you use 50, which is the original symmetric key, then you are going to get the message back. So that's how the symmetric key cryptography works. It uses the same key for encrypting and the same key for decrypting. Okay, I have I have one more example here, which is public key encryption. So this is not a typical, it does not follow any RSA or any specific algorithm. It's a custom algorithm, I would say. So let's generate. So again, generating this public private key pair is an important topic. So it has to be mathematically linked, and the key generation also is a very crucial topic. So we'll talk about that little later. Public key. Let's take this example. For the public key 123, the corresponding private key is 36. Okay. Or public key 52, you have private key of 107. So again, this is not RSA, so don't correlate to any prime numbers and other things. It's a custom implementation. So just for making you understand what it actually means. So the public key is something which you share with others. Private key is something which you keep with yourself. Okay. So let's say, so first is you want to sign a message. So again, we are going to talk about the difference between digital signature and some of the other applications, like just encrypting message and sharing with something like a web application. Okay, so both are different use cases. The reason is you can just see when you are signing the message, you're actually using the sender's private key. Means it's my private key. So I will look at my private key 107, and plain text is just test me, and then I'm going to encrypt this message. So this is a signed message, which means that only I could have signed this. Nobody else would have been able to sign this information. So usually done for digital signature or some online signature where we are not able to be physically present, right? So we would have probably gotten into some situations like that. Now with pandemic and all, you are not going to be physically present, so they ask you to digitally sign. So this is what is happening in the backend. So this is your signed message, and let's go to this decrypting of signed message here. This is the cipher text or the encrypted text, whatever you want to call it. So this is the recipient's private key. Okay, this is not the. So this is the signature part. So this is. I think please don't get confused here. So this is a private key of the sender, which is sharing a signed message. So it's not going to share the plain text, but a signed message. And then you have the decryption of the signature, which is also called as the verification of the signature. Okay, so signed message goes here, and public key is the sender's public key is one thing which you share with everyone, right? So you share. So I have signed the message, and this is my public key. You can go ahead and verify. Okay, so you can verify this, and they will compare it with what plain text they receive, right? They receive the plain text as test me, right? Which means that the whatever message which he had sent with a signed message are both matching. Okay, if any one of these parameter changes, it will not work. Okay, so that's the message about verify signature. We are going to talk about this in detail. Just hold on, hold your thoughts. Okay, and I want to show you one more example here to encrypt just a message. So any message, yeah, when you are encrypting a message, yes. So let's say yes, and then so this is when, for example, you want to send a message to a web application or a party who has shared a public key with you. So this is the opposite of a digital signature, right? So you get the recipient's public key. So a recipient has shared their public key, and you can send any message to them, and only they can read it. Okay, so let's say let's encrypt the message. So this particular message no one else will be able to understand, only if you have the key to decrypt the message, that is the recipient's private key. Only then we will be able to receive the message. So let's try with some value. It will not be it will not decrypt, or it will not work. So let's say this is the private key. Let's try to decrypt, and then you get a message. So this particular example shows that yeah, a external party can send encrypted messages to a person who has shared their public key. Okay, so we'll see some of the applications and examples in the next part of our session. So we have another 20 more minutes in today's session. I would like to use it for talking about a particular a couple of use cases, and then we can call it a day, and we'll come back tomorrow and expand on our learning. We'll be talking about hashing, we'll be talking about digital signature, we'll be doing hands-on exercises with respect to RSA as well as elliptic key cryptography. Also, we are going to understand some of the topics on the attacks for the cryptographic functions, and how we can how it is negated, right? So a lot of interesting things coming up. So I let's switch back uh, to our session. I think you'll not be able to see. So let me just cover one more point, and then we can come back to our session. Okay, so similarly, so there is a another implementation of the AES encryption. So AES 128 bit or 192 or 256 bit. So let's say this is some test me, and then you provide a key, right? So it can be any numerical value, and then you encrypt this particular message, and this is what you get. Okay, so this can be just text message, it can be file or anything for that matter. So usually the AES data uh, encryption at rest is done using the symmetric key cryptography, where keys are managed either completely by the cloud provider, or there are key management arrangements which are made, where both the client as well as the cloud service providers are equally responsible for the key management, right? So there are different schemes which are provided by Amazon Web Services. Similar features are provided by Azure also. So you can look it up if you are very keen on that. Okay, so when I switch over to decrypt, so what I would do is I would put in the encrypted message. Oh, I actually forgot uh, the I think this was the one. So let's see. So if I want to decrypt this, yes, it is test me. And if I use any other number, it will not work. Right, something has broken. Anyway, so one good thing is, if you want to implement this, there are different, there are some codes which are provided. I would like you to give this a shot by implementing it yourself in your own systems. So there is a PHP implementation. There is also a Java implementation. So whichever language is favorable to you, you can give it a shot. Okay, so that may be one of your homeworks that you can do after this session. All right, so let's come back to our discussion. So at this point of time, I would like to for you to kind of have an introspection. And We couldn't. Okay, so I will look at the questions later, but I would like you to introspect and even use chat for that matter to share your feedback. So do you think we can use only symmetric key and be perfectly fine with all the security requirements, or do you think we can do only with asymmetric key cryptography, or do you think we should use both mechanisms and use it in a smart manner, wherein we can do effective communication with any two systems? You can answer. Please share WhatsApp. Okay, so I want, depends on the application and purpose. Hybrid, great. So you can type the answers. So whether you want to use only asymmetric or symmetric or both. So both, very good. I see answers asymmetric. Asymmetric key, I will with the next use case, I will bring out uh, the shortcoming of using only asymmetric key. Okay, but the right answer is both. So kudos to everyone who has answered. I think Tarun Preet, Anupama, Sahana, Paramjit, Saurav, great answers. And Monisha and one more person who answered asymmetric, Sabiha. Just give it a thought. By end of the session, you will understand why both are required. And definitely, like it depends on the application. Like I think someone mentioned, Tirupati mentioned, depends on the application. But on a grand scheme of things, we would need best of both schemes, right? So let's see how it works. So one of the use cases which I want to talk about is PKI. PKI is public key, or you can I think best related to the protocol HTTPS, right? So you have HTTPS protocol, where we originally, if we go back to the our man in the middle attack, let's go back to this particular man in the middle attack. So you have a user who wants to access a web application, and their connection is kind of compromised because of the man in the middle.
Sir, we are not able to see your slides.
Okay. Thanks for reminding. I think it's because I'm able to share only one. Okay, so I'm in this particular slide. You didn't miss much. Okay, so I wanted to talk about the use case of HTTP, how HTTPS protocol works, right? So if you can go on mute, it will be very helpful. Okay, so when you talk about the HTTPS protocol, a user is trying to communicate with a web application in a secured manner, right? And before HTTPS was introduced, the secure socket layer or even the TLS protocols. So you have just the plain text protocol, which was HTTP, hypertext transfer protocol, right? So it was just a plain text exchanges, and it was not security was not even thought about when created, because it was just for exchanging information, and we thought, people, all people are trustworthy and whatever it is. So it was never thought security was never thought about it when it was built. So when we started doing transactions like banking or even e-commerce or social networking, when privacy or the security became more important, then we had to encrypt the message, and otherwise we could have been prone to man in the middle attacks. All right, so even there have been a lot of evolution where a particular methodology of encrypting like TLS 1.0 or the SSL, all of them were having some vulnerabilities being discovered. So based on that, some newer innovation came into picture, and right now TLS 1.3 is also there, and TLS 1.2 is considered to be at least the baseline security, and TLS 1.3 is the best level of security which can be provided for secure transaction. Okay, so that is the example or the use case which I want to take with respect to the encryption methodology. Should we use only one or should we use both? Okay, so the way in which the HTTPS works or the PKI works is that when individual application or a user is trying to contact the web server, the computer will take up the public key of your web server, encrypt the message, and send it to the web server. Okay, so this part is very clear. So only web server will be able to decrypt the message and identify that okay, this is the person, and respond back to the person. But the problem is, if the server just uh, is able to kind of use its private key to send message, encrypt the message, and then send it back to the computer, the man in the middle attack is going to come back again, because now man in the middle has the public key of the web server, and if the message is sent with the private key, even though these are like interchangeable and then exchangeable, right? So they will be able to decrypt the message which was intended to the original recipient. So the second way of communication, the message which is going to come back, is never going to work with just asymmetric key cryptography, because the second the message which is coming back will be prone to man in the middle. So we have to use a smart way in which we switch over to a secret key cryptography, that is a symmetric key cryptography. Okay, the way in which it is done is when the computer or yourself, when your browser is sending message to the web server, so in the initial message, so it is using the public key or the public certificate. We'll see the digital certificate, we'll see in just a few minutes. So it is going to uh, put in a session key or a key which is used, which is going to be used for further communication, to switch over to symmetric key cryptography. All right, so that is going to be part of the encrypted message. Using the public key, it will send again in the data packet. Hello.
Hello, sir. Tell me.
Hello.
Hello.
I'm hearing some noise. Can you please go on mute? I know I have another 10 minutes. I would request for say another 5 minutes extension, and I'll wind up by around 4:30.
Varun?
Yeah, ma'am.
Sorry. Actually, we have, this is an announcement to all the participants. All of you would have received an email with your Atal registration ID. Okay, so there is a feedback form sent in the chat window by Karthik sir. Kindly click on that. This is for the participants. Kindly click on that and enter the feedback, because we're supposed to take every session feedback actually, but we are taking it at the end of the day for all the sessions conducted on that day. Okay. So all the participants, there are 116 participants here. We require feedback from all of you. Please click that Google form and finish the feedback, and then only leave this meeting, because these are all mandatory things we have to submit for AICTE. So therefore, if we don't receive feedback from you, we'll again have issues of issuing certificate, etc. for you. So kindly click the feedback link, give your feedback. It will take hardly 2-3 minutes for you. But when you do that, there are two data entry fields. The first data entry field is your Atal registration ID. Where do you get that from? You would have got an email from us talking about the Atal registration ID. So you're supposed to enter that. And you're also supposed to enter our Atal application approved number. Both of that is given in the feedback form. From the email, collect your ID, enter the ID. And on the top of the feedback form, you will find an Atal application number that also you're supposed to enter. Enter your city and wherever you have logged in from. These are the 3 data entry fields. Rest of them are what is it called? Radio button. And yes, like Dr. Prabhakiran, if everybody could tell in the chat window, done, done, done. And if we get about 118, we are happy. Okay, so please.
Ma'am, can you please configure the form? Can you please configure the form to send us the response receipts? Because we are not sure whether the form is submitted or not.
Okay, as of now, we haven't. Today, let us leave it like this.
Yeah,
Tomorrow
please.
onwards, we'll do that, sir. Thank you for the feedback. We'll accommodate that. Okay. Bye. Thank you. Go ahead, Varun, please.
Yeah.
And kindly stop at 4:30 because many of them are faculty and they'll have to leave in their most of us are all faculty, I think, across India are working. They're not in offline mode. Online mode. So most of us come to college, so they may have college buses and other things. So kindly end by 4:30. Okay.
Perfect. So we'll accommodate the things in tomorrow's session.
Right. That's okay. Thank you so much, Varun.
Excuse me, ma'am.
Yes.
One query. While putting the registration ID, only last digits are fine, or we have
No, you need to copy the entire list Atal / whatever we have given.
Okay, whole thing we have
Yes,
to.
please. Yes, please. Please do that.
Thank you, ma'am.
Yeah. Thank you. Yeah. Sorry, Varun. Please go ahead.
No problem. All right. So just to continue the thought process. So once we have the browser is going to send an additional session key or a symmetric key along with the initial message, which is encrypted using the asymmetric key cryptography methodology. And from the second communication onwards, which is coming back to from the web server to the user, it is going to switch over to symmetric key cryptography. All right, so this is the perfect use case for depicting the perfect marriage between asymmetric key cryptography as well as symmetric key cryptography. All right, so this is what I wanted to share with you. Probably if you have any questions, we'll take it up in tomorrow's session before we get started. Okay, so at this point of time, I'm hearing some noise. Okay, so I want you to understand a specific topic, and probably we'll touch upon this tomorrow, and we'll start from this topic tomorrow. Is who is going to provide this particular public key, private key, and how can we trust anyone, right? So how do we trust that it is a public key, and how do we ensure that private key is corresponding to the public key? So all these things are there is a very good mechanism which has been implemented for it. So I will show you something. I have a small homework also for you, which is related to the digital certificates, right? So you might have looked at this particular digital certificate on your web applications. Okay, so here one of the things is the fields in the details. If you go, you'll see public key, and it will say which algorithm is used. So it says, so one on the left, it says RSA and 2048 bits. And one on the right, it says ECC, which means that this particular website is using elliptic curve cryptography, and it's just 256 bit. So this is what I was trying to say earlier, that elliptic curve cryptography can provide a similar or higher level of security with a shorter key length. Okay, so this is one, and I just wanted to touch upon this random numbers, but I will not be able to do justice for this particular topic. But random numbers is, like I think mentioned before in the session, are very important with respect to cryptography. There are no true random numbers, so we use pseudo random number generators. There are multiple different ways of doing it. So one of the homeworks which I want you to work on in today's session is, I will show one, and you have to list down any 4 major trusted certificate authorities which provides digital signature, digital certificates for websites. I'll show you one, and you can share. You have to list down at least 4 others. Okay, and then if you have time, and if you want to explore some coding, you can explore the option of implementing any random number generator, any algorithm that you choose. Okay, so I will show you one, and I will share my web application and the link. Okay, so so I hope you can see my screen, the web application. So I can choose anyone. So when you look at this lock symbol on the web page, you will get the certificate details. No need to worry. I will be explaining this in tomorrow's session. So if you look at the details, you will see the signature hash algorithm. You'll also see the public key which is used, which is RSA, and there are this particular certification path which tells you who has actually provided this particular certificate. Okay, so who has issued this particular certificate. Okay, so in this case it's Zscaler. I'm in a controlled environment, so we use Zscaler, but different. If you look at it from your system, it will be different provider. For me, it will be Zscaler everywhere because I'm in a controlled environment. But from your side, each of the web applications, if you look at it, it will be a different. So what you need to do is you just need to find out at least 4 different certificate providers and list it down. So tomorrow morning we'll have a quiz, or we'll just see if everyone, you can list it out. Okay, and second one is on the random numbers. I would leave it to you if you can, if you are able to implement some random numbers, pseudo random numbers. We'll start our conversation with that and proceed further. Okay, and last one, we have 1 minute of time, so I just wanted to just close it on a high note with I will share a in chat. I'll put one another quiz. It's same Mentimeter. Okay, if you can go open that particular Mentimeter, and I will present that here. So if you can answer those questions, I have just a couple of questions. We'll see. We'll just use 30 seconds for the first question, and the another 30 seconds for the other question, right? So how can we secure a system, right? Password, great. Fingerprint, okay. By password, okay. Great. Keep the answers coming. So another 20 seconds left. Yes, you can. I see someone has put hello message, so you can submit multiple times. That's not a problem. Okay, biometric, great idea. Encryption, yes. Password, avoid unknown. I think it's a half sentence. Face recognition, I think it's on the biometric part. Pattern, QR code, face detection. Okay, a lot of people somehow influenced by biometrics. Great to see that. Okay, so let's go to the next question. So HTTPS, I think this is the question if it will decide whether you have understood the concepts today or not. So it's a litmus test to me as well. So HTTPS is using which encryption? Is it using only symmetric key or asymmetric key or both? Great answers coming in. So we'll We'll have another 30 seconds for people to answer. Great to see everyone answering, giving the right answer. So that's great that you have grasped the concepts for today's session. For the person who has answered symmetric key, yes, it uses symmetric key, but it's not just symmetric key. To shift to symmetric key, first you would need a asymmetric key cryptography, and then you use the symmetric key. So and the correct answer would be both. Right, thank you so much for your time, and if you have any questions, okay, so some of them have been answering in the chat window also. Great. So all of them are right answers. Both is right answer. So use both asymmetric key to start with, and then it switches over to symmetric key cryptography. Okay, so I will be sharing the presentation and the reference links, and we'll continue our conversation. A lot of things to be shared tomorrow: hashing, digital signatures, elliptic key cryptography, and a lot of other topics. Very interesting session. So I would love to share it with you. So we'll meet tomorrow at 9:15 a.m. I believe. Yeah. So thank you so much for your patience, and let's talk again tomorrow.
1 second, sir. Sir, Dr. Varun M. Deshpande, this is Karthik, professor with MSRIT. Sir, I just wanted to thank on behalf of MSRIT Department of Information Science and Engineering. As this session has started from the beginning in terms of the introduction to cryptography, I think most of them will be learning all these basic concepts of cryptography and then all. But today they might have got a brief idea about what exactly is a symmetric key and non-symmetric in terms of encoding and then encryption. Basically, what exactly all these are all about. And then symmetric systems with pros and cons, then with asymmetric one, and then PKI works with the digital certificates and then certification authorities. All this which we briefed about all this in terms of the practical way, and this approach is really good and very informative one, sir. On behalf of our college, I would like to thank you so much for sharing your knowledge with us and giving time for us to work on this particular FDP. Thank you so much, sir. So we'll meet you tomorrow for in-depth in terms of very helpful, joyful session tomorrow morning.
Absolutely. Absolutely. Thank you so much. Thank you.
Thank you, Varun. See you.